Hi there. My name is Brian Arnold, and I'm a sound designer. I'm a technical sound designer and a music composer. And what you're seeing now is a game called Chaotic Cadence. I made this for the Ludum Dare 49 Game Jam in October of 2021, and I had approximately 72 hours to complete the game from start to finish. This was my very first attempt to make a game on my own, and here it is, with all of its bugs, its spaghetti code, and its rough edges. What I'm going to do is I'm going to play through a level to show the basic gameplay, and then I'll demo some of the features that I experimented with. So, as this was my very first game, I hadn't worked with a lot of components in Unity specifically, like creating particles, creating animations, creating a physics-based movement system, working with scene transitions, and quite a bit more. And so because of that, I knew that having only 72 hours to work with meant that I really needed to keep things pretty simple. So aside from the basic 2D shoot 'em up gameplay, I was interested in trying to add some rhythmic components to the game that might give the visual and the audio elements a more cohesive feel, and that's what I'd like to show now. The first element was probably the simplest and most noticeable, and that was the pulsing color frame. As you can see, the pulse rate is tied to the tempo of whichever piece of music is playing, and it pulses on the quarter notes of the song. The other rhythmic elements are tied to the enemy behavior. The first is the enemy firing pattern. When they shoot, they do so based on the main melody or the rhythm of the music piece that's playing. The second rhythmic element controls when a group of enemies spawn. When there are no enemies present on screen, the game will wait until the next time the first or the third beat of a measure occurs before spawning a new set of enemies in. The final rhythmic element is the enemy movement. Every third beat of a measure, the enemies have a certain probability to shift their position to a random location on the screen. And if that probability passes and the enemies are going to move, they will start a shaking animation on beat 3, and it will continue all the way to beat 1 of the next measure, where they will suddenly transport to a new random position on beat. Now, all of these rhythmic elements are controlled by MIDI files. I used Fmod as the audio middleware for this project, which did not have MIDI support at the time I made the game. However, I was able to find a really wonderful open source class library called DryWet MIDI, and it gave me the tools I needed to be able to parse a MIDI file and to collect, store, and use the data that I needed. Let's take a look at the MidiManagerBeat Prefab. This game object is responsible for tracking the beats of a piece of music, and as we can see, it holds references to an Fmod music event. It holds the location of a MIDI file, and it also holds the tempo of the particular piece of music. The MIDI file that's used for tracking the beat was made in the Logic Pro project that the music was composed in. If I navigate over to the Logic Pro project, we can see that there is a MIDI track here that is called Beat MIDI. This MIDI region has a MIDI note on each beat of the measure, and each beat is a different MIDI note. This way we can track not only when a beat has changed, but we also know which beat we've changed to. So for instance, beat 1 of every measure is a D, beat 2 is a D sharp, beat 3 is an E, and beat 4 is an F. This MIDI region was exported as a MIDI file, and it was added to the streaming assets folder in the Unity project. And it's this MIDI file that is referenced inside of the MidiManagerBeat. If we take a look at the MidiManagerBeat script, we can see that there's a bit going on here. I won't go into extreme detail, but I will hit the high points. But if you are interested in digging further into the details, the project is on GitHub and is available to download. The link will be in the description. The first key area of the script is the onBeatChange event. By creating a static event, other classes can subscribe to this event and they will be notified when the beat changes, and then they can react accordingly. Next, we look at the Unity awake callback. When the MidiManagerBeat Prefab is loaded into the scene, it calls the setInitialMIDI file data function. As we can see just a little bit lower, this function calls a collection of 3 other functions. Without going into the weeds too much, the readFromFile function reads and stores the MIDI file that we assigned in the editor. The getDataFromMIDI function gets the specific data from the MIDI file that we need, specifically in this case, all the notes in the MIDI file and their timestamp locations. And then finally, the setTimestamps function converts the timestamps into milliseconds, and it stores each of them in an array that can be referenced in the future. Now that the MIDI data is stored and ready to be used, the Unity update callback calls the check for beat change function every single frame. If I scroll down, we can see the check for beat change function down here. We first check to make sure 2 things are true. First, we want to make sure that the music has not looped, and we want to make sure that we are not trying to read the timestamp array at an index beyond its count. We then check to see if the timestamp of a beat change is equal to or less than the current timeline position of the fmod music event. If these conditions are all true, then we know that a beat change has occurred, and we call the setBeatValue function. We then invoke the onBeatChange event, and we pass in the current beat integer as well as the current beat string value, both of which had their value set in the setBeatValue function. Now, any classes that are subscribed to the event are notified of the beat change. For instance, the color frame pulsing animation is controlled by the BeatPulse Script here. As we can see, the script subscribes to the onBeatChange event. And when the onBeatChange event occurs, it starts a coroutine called BeatPulse Timer. This coroutine, found down here, controls the color pulse timing based on the tempo of the song. In a similar way, the EnemyManager Script also subscribes to the onBeatChange event. When the event occurs, it checks to see what the beat value is, and depending on that value, it may call different functions that control the spawning of enemies, the shaking animation, and the random repositioning of the enemies. And so that about wraps up the different rhythmic elements in the game. If I had had more time for development, there are other game design ideas that I would have loved to have added, as well as just taking the time to kind of polish and clean up the architecture of the project. But that's the nature of game jams. I may come back to the project and flesh it out in the future, but for now, I'm exceedingly happy with what I was able to put together in a relatively short period of time. If you're interested in playing the game for yourself, I've put a link in the description to the Ludum Dare game page that has the download links for both Mac and Windows computers. And again, if you'd like to take a look at the project in detail, it's been uploaded to GitHub, and I'll leave a link for it also in the description. And so I'll close out the video by playing the final level of the game. As always, I hope you enjoyed the video. Thanks for watching.